Okay, so this is the answer key video for your Trig1 assignment part 2. So feel free to skip around to any particular problems that you had difficulty with. You do not have to watch the entire video. It's just here for a reference for those that you had difficulty solving. So just a couple words about the reference table they provided for this assignment. And the first thing I'm going to point out is this letter theta. And you're used to using the Greek letter pi, so that's not scary. But when we talk about angles, a lot of times we use this letter. It's a Greek letter. Looks like sort of a fancy O. I don't know how you draw it. It's got like a line through the middle. It's got the Greek name for this letter is theta, and it's often used to represent as the variable to represent angles. So you can see here they say angle theta, and then they give theta is the degrees. You can see it down here in the triangle, and we have 0, 10, 20, so this would be 30 degrees. So if you were looking at a 30-degree angle for this, theta would be equal to 30. So it's often in science and math we use Greek letters for variables. So the first problem we have is we have a triangle, and it asks us to find the length of the opposite leg to the 80-degree angle. So here's the 80-degree angle. We'll mark that in blue, and the opposite leg is going to be this side. So we have to give it a variable. So let's call it x. And so I can see that I know the opposite side is x, and this is the hypotenuse because it's opposite the right angle. So I can use opposite over hypotenuse to find this. And the angle's 80, so I'm going to look at my chart here. I'm going to look at 80. And so we're going to say, okay, opposite over hypotenuse. Okay, I looked that up, and it is 0.9848. That's going to be equal to x over 24. So my answer is going to be x is equal to 0.9848 times 24. And the answer to that would be 23.6352 is what comes out of my calculator. And it says the approximate angle. Notice that they gave us the other to a whole number, so I'm just going to say that this would be 23.6. I'm not going to round it to 24 because that would look strange, right? It's not really 24. This is 24 in length, the hypotenuse. The hypotenuse is always the longest side, so we're going to round to the tenths place. The next angle we're interested in is 45. So here's our column with 45 degrees. And we can see that I can see on here that I am, the opposite side is 7.1. I do not know the hypotenuse, but that's what I want to find. So we're going to give that a variable x. And so how are we going to do this? Well, let's say that we're going to relate the side opposite and the hypotenuse. So that is going to be the opposite over hypotenuse is 0.7071. And so that is going to be equal to, the opposite side is 7.1. The hypotenuse is x. So we're using the opposite over hypotenuse ratio. And to solve this, again, you could put a 1 underneath and cross multiply, but the answer is going to be x equals 0. Actually, x equals 7.1 divided by 0.7071. So I'm going to get a number bigger than 7.1. And this works out to be x is going to be equal to 10.04. So we're going to go to the nearest tenth, and so this is going to be 10.0 is the answer. Problem 3, they want us to find the length of the hypotenuse. So here is our hypotenuse. Let's use a different color. Let's use red. So there's my hypotenuse. I can see that I know the adjacent side this time. So this is my adjacent side. And so adjacent and hypotenuse for a 60-degree angle. So the 60-degree angle is going to be right here. Adjacent and hypotenuse is going to be a half. So 0.5 is equal to the adjacent over the hypotenuse. And so my adjacent side is 0.7. My hypotenuse, I don't know what it is. Let's call it y this time. And so y is going to be equal to 0.7 divided by 0.5. So that's going to be a number bigger than 1. And let's see what we get. And the answer we get is 1.4. So 1.4 is the hypotenuse. So in problem 4, it asks for the length of the adjacent leg. So we're looking at a 40-degree angle, and the adjacent leg is this leg right here. This other side that we have marked as 18 is the hypotenuse. And so we're using the adjacent over hypotenuse. So adjacent over hypotenuse. We can look that up. That is 0.7660. And the adjacent side, we don't have a name for it. Let's call it W. So W over 18 is equal to 0.7660. So W is going to be 0.7660 times 18. So it's going to be smaller than 18 will be our answer. And that comes out to be 13.788. So since we're rounding the nearest tenth, we're going to say that's 13.8 would be the adjacent leg. So for problem 5, we have a 30-degree angle. So here's the 30-degree angle. And we're looking, we know the hypotenuse. We do not know either the adjacent or the opposite side. And so it says find both legs. So let's do both. So it doesn't matter which one we start with. Let's call the adjacent side X, the opposite side Y. So if I'm looking at the adjacent over hypotenuse, that's equal to 0.8660. 0.8660. And so the adjacent side is X, the hypotenuse is 12, and so my answer is going to be 0.8660 times 12, which is going to be a number smaller than 12. And that comes out to be 10.392. So we're going to say 10.4 would be the adjacent side. And then let's switch to a blue pen. And so when I do opposite over hypotenuse, okay, that's 0.5. So we have 0.5 equals y over 12. And so y is going to be half of 12, which is going to be 6. So y is 6. In problem 6, we got to make a picture. It says Main Street and State Street are perpendicular. So let's see if we can draw something like that. So Main Street and State Street. So we'll call that Main, and this is State. Laurel Street and State Street intersect at a 50-degree angle. So Laurel Street and State Street intersect at a 50-degree angle. So somewhere here we have a 50-degree angle here. So this is Laurel Street, this red one. The distance along Laurel Street to Main Street is 0.8 miles. So on Laurel Street to Main Street from State Street, so right here to here, this is 0.8 miles. If Laurel Street is closed, between Main Street and State Street for a festival, approximately how far is it to the nearest tenth will someone have to travel to get around the festival if they only take these two streets? So this person is, they blocked the street off at these green dots, these points here, and they're having maybe a giant block party or something. And so to get around it, you have to go all the way down here to the right angle and then go up. And they want to know how far that is. So we have to know the both legs of this triangle. We know the hypotenuse is 0.8 miles. So let's see if we can calculate this. So we're going to have to give it a variable. So let's call this perpendicular distance x. Well, actually, no, it's going up and down, so maybe it makes more sense to call that y. And then the horizontal distance x, because we usually do that anyway. So we have x and y. So we're going to have to use the opposite over hypotenuse and the adjacent over hypotenuse. So let's do the adjacent one first. So here's the adjacent side to the 50-degree angle. And so if I look up 50-degree angle, the adjacent is 0.6428 is the adjacent over hypotenuse ratio for a 50-degree angle. And so I have x over 0.8. So I'm going to multiply 0.6428 times 0.8, and x is going to be equal to 0.51424. So we're rounding to the tenth, so we're going to say that horizontal distance is a half a mile, 0.5. And now we have to find the vertical distance. So we're going to look up the ratio for opposite over hypotenuse, and that is 0.7660. And that's going to be equal to y over 0.8. And so y is going to be 0.7660 times 0.8. And what we get is y is going to be equal to 0.6128. So this is going to be 0.6 miles. Now notice from my picture, I'm just going to point this out. This was just a sketch that I drew, and it helped me solve the problem. But clearly it's not correct, because if I look at this length here, this is clearly a smaller length than this length. And so the distance here is marked as a half mile, and this is a little bit bigger, even though it looks smaller. So that's part of that thing where diagrams can help you solve a problem, but a lot of times they're not really accurately drawn. But they still can help you solve it if you trust the numbers and the relationships. Okay, in this last problem we have a big pole that's going up, and they have like an anchor cable. Sometimes you see this for poles. They kind of secure them into the ground so that they don't tip over and start to lean. And they tell you the angle that it forms with the ground is 70 degrees. So this is the pole going straight up. This little wire going along here to the ground has a 70-degree angle. So the distance from the base of the utility pole to the anchor pole is 3.8. So here's the base of the pole. Base means bottom. And here's the anchor point. And they tell you that this is 3.8 meters. So let's go ahead and label that on our picture. So I'm going to take my pen and I'm going to write 3.8 meters. And the question they ask us is, how long is the support cable? So I want to know this length. Now, look, if I look at that picture, I can clearly see that there's a triangle there, right? So here's my triangle. And I'm looking for the hypotenuse of that triangle. And I know the adjacent side, because remember, it's relative to the 7-degree angle. So 3.8 is the adjacent side. This is my hypotenuse, so I'm going to call it h. And so I'm going to be looking for a 70-degree angle. I'm looking for the hypotenuse and adjacent ratio. So that's this one. And so adjacent over hypotenuse, we know that that ratio for a 70-degree angle is 0.3420. And I know that my adjacent side is 3.8, and my hypotenuse is h. And so I can cross multiply, or however I want to manipulate that, but h is going to be equal to 3.8 divided by 0.3420. And that turns out to be 11.1 repeating. So 11 and 1/9. And so, it keeps going. So we're going to just say 11.1. So this is 11.1 meters. Now, in this problem, it just asks you to think a little bit. It says Indy, It's an unusual name. It says that the ratio of opposite over adjacent for an angle of 0 degrees has a value of 0 because the opposite length is 0. What does she mean? Well, if we just kind of make a picture here, so I think about this angle, whatever the angle is, let's use that new letter, theta, that we talked about. So this angle theta, and right now it's not 0, right? And I'm going to think of this side of the angle just staying still, but then I'm going to move this side so it gets smaller. So I keep moving it down, I keep moving it down, I keep moving it down. And what's happening to this vertical distance each time? It's getting smaller and smaller and smaller. And when the angle equals 0, when theta equals 0 degrees, this vertical distance right here is also going to be 0. So that's what she means. She means that, if you have a angle with 0 degrees, that there's no vertical distance. And so the opposite over the adjacent is going to be equal to 0 because the adjacent's always got whatever length it started at, it's going to be the same. So that's not changing. But this is getting smaller and smaller until it goes to 0. And so we get 0 for the answer. Actually, it's not 0 degrees. I shouldn't have put the arrow there. But it's getting smaller and smaller to 0, this 0. Yeah.